So we are given a set of data, and we have to find their linkage groups and the order of the genes in each linkage group and the distance between each of the genes. So our recombination frequency, that's also going to be our distance in centimorgans between each gene. So we don't really have to do any math there. So really what we need to do is just find the linkage groups and the order. So for the step one, I do these a little bit differently than what was shown in class. I like to start with the first gene, which with us, we're given genes A through F, so that's A. So we'll start with A, and first I like to find what which ones they separate independently from, so we know that they're on separate chromosomes. So we find the 50% recombination frequencies of A, and we know that with the data given that C, E, F, and G are on separate chromosomes. So really what we need to be considering on this linkage group is A, B, and D. So we go back to our table, A, B, and D, and their linkage groups, and I've transposed it here in step 2 to find the linked genes for A. We know that between A and B is 10, and between A and D is 14, and between B and D is 4 centimorgans. I like to show them like this because they're just little puzzle pieces, and literally all I have done is taken this little chunk and over here, and then I took this little chunk and placed it over here. So I put those beside each other, and you see how my little puzzle pieces, they have B and B next to each other. So that's how we know that these are on the same linkage group. So A and B are 10 apart, B and D are 4 apart, and then A and D are 14 apart. That one adds up, which is nice. There's one later on that does not add up. So after we figure out those, now we're finished with A, B, and D. So let's cross out everything that has to do with A, B, and D, just so we're not confused. Those are all of the variables with A, B, and D, and at least one of them. So now all we really have to look at is the remaining data to figure out our next linkage group, A, B, and D. So let's go on to C. Our third step is going to find the 50% recombinations for C. C and D obviously are 50%, and then C and F are 50%. So those are on separate chromosomes. And we already know A and B are on separate chromosomes because we just finished their linkage group. So we don't need to worry about that. So really what we're looking for here is everything but A, B, D, and F. So what's remaining is C, E, and G. So we go back to our data table when we find that C and E are linked with 8 centimorgans, and then C and G are linked with 12 centimorgans, and E and G are linked with 18 centimorgans. So we can already tell right now that these are not going to add up, and I'll explain why here in just a little bit. Little puzzle pieces, and we transpose them, and we take the puzzle piece and we transpose it. E and G are 18 apart. So that 12 and 8 adds up to 20. So why is this 18? Sometimes if they're far apart on the chromosomes, it's just because of double crossovers, and that just happens, but you usually want to be within 5% of each other, which 20 and 18 are. So we're good there. So now let's go back to our data table and figure out what we're finished with. We're finished with A, B, C, D, E, and G. So these are all the variables we crossed out with our first linkage group. And these are all the variables we can cross out with our second linkage group. Effectively, we have crossed out everything. But what are we missing? We're missing F. What about F? So let's just go back to a blank data table and find the remaining genes that we have left over. And we see that all of these variables, F, has a 50% recombination factor between A, B, C, D, E, and G. So the only logical conclusion is that F is sorting independently of every other gene. So now all we really have to do is just put it all together. We have 3 linkage groups with the data given, our A, B, and D linkage group, and our E, C, and G linkage group, and we have F sorting independently.